If you would have told me 5 years ago when I was building this Koenigsegg CCX that I would have the power of this ridiculously expensive tool in the palm of my hands to build whatever it was that I felt like building, I honestly don't think I would have believed you. You see, back then I was tasked with taking off the twin superchargers attached to the engine and then building twin turbo system to replace it. And this guy holding onto this $70,000 friggin' scanning arm was hired out by me to get some scans of the engine bay just so I could model the manifolds. Now, unfortunately, I never got to finish this build, and that's why I never made a video about it, because the owner sold it before I could finish it. But either way, the day has come where a small tool like this can completely change your fabrication game, and after being in this industry for so long, I can confidently say that you guys have it so friggin' easy these days. And you really need to start thinking about getting tools like 3D scanners and CAD into your arsenal, because you can make so much money and build just about anything. That back end just sticks. Dude, this is freaking awesome. I'm a firm believer that every fabricator should have their own beater car, and this one is mine. It's a 2004 Mitsubishi Lancer Ralliart. You can think of the Lancer Ralliart like an inbred child of the Evo and the base Lancer model. It has an upgraded 2.4-liter engine with MyVec, which is kind of like Honda's VTEC, except it actually does something other than make noise. It also comes from the factory with bigger brakes, a more sporty suspension, kind of like the Evo, and it also has a factory front strut tower brace and bigger sway bars. Now, every single chassis that's ever been made has a bit of a problem that every single manufacturer has had to solve. The sheet metal that every chassis is made out of needs to be strong to hold everything together, but also light enough to keep the weight and ultimately the cost down. The result on inexpensive grocery getters is usually a sloppy chassis that the average driver would, not even really care about. So, if we want to add a little bit more stability and rigidity to the car's handling characteristics, we add some bracing. An old school trick is to take a simple little tube and tie two mounting points of, let's say, two control arms together, and you wouldn't believe how much of a huge difference that makes. Now, the footage that you're seeing is actually coming from a future episode where I use a little bit more primitive tooling and design as opposed to the one you're going to see today. So make sure that you're subscribed and notified so that way you don't miss it. Now, the back end of the Lancer has a factory sway bar, but it's just a little bit wimpy. Yeah, I'm sure it's kind of effective, but really, we can do a lot better than that. What I want to do here is add a brace to the lower control arms to add some rigidity to it. Now, if I can come up with a clever design that ties both the control arm mounts together and then bend up my own larger sway bar, then we basically kill two birds with one stone. Now, if we add a little bit of style to it, then we basically have ourselves a product that we can call our own, something that we're really proud of. And in order to make that design quick and easy, I'm going to use a scanner. But first, if you're struggling to learn how to weld, you should strongly consider booking one of our in-person TIG classes. Since 2017, we've been offering hands-on, in-person TIG welding classes, and our single-day aluminum and steel TIG class is hands down the fastest way to learn how to TIG. With no college courses, no prerequisites, no experience necessary to attend. We also offer 2 locations for learning, either here in Vegas at my shop or at the PrimeWeld headquarters in Blackwood, New Jersey, just outside of Philly. At the PrimeWeld headquarters, we also offer a single-day stainless steel only TIG class for more experienced welders looking to up their skills. So if you want to learn how to TIG weld from a pro or just up your existing skills, head over to thefabricationseries.com and book a class with me. You can also use the code TFS50 at checkout for $50 off any class. I hope to see you there and teach you how to TIG. Let's plan out our scan real quick here, because there's information, and I don't know how many people actually talk about this, but from the engineering standpoint here, really consider what information do you actually need. First and foremost, I need to know where the assembly is going to mount to, which is going to be this tie or this point right here and this point right here. That's super easy, right? This hanger right here, it's an obstruction, so we need to make sure that we know where this point is here, all of this stuff that's in the way, this hanger. We need the back side of the muffler, not the whole muffler, because the whole muffler is, it's pointless to scan all that because the sway bar is not going to go anywhere around this section, so that data we don't need. We definitely need to know where this exhaust tube is or where it's sitting, because that's going to represent the window of area that we have to work with here. We're going to want this pickup point exactly or precisely where it is, and we're going to want the side of this coil spring here on the strut assembly. We're going to want that, maybe some of the control arm, etc. Where it drops down right here, this is going to indicate whether or not we have enough clearance on our assembly, and then how far it goes up into in there. We might need to utilize some of that section. Now over here, there's nothing in the way, so I don't care about any of this stuff over here. All we have to do is model this half of it, which will save some time, and then we'll just mirror it, and then we can double check and make sure, yeah, it fits in all the spaces that we want it to fit in. That's how you plan out your scan. Scanning for the modern day enthusiast has really taken off in the last few years. There are literally thousands of models to choose from, and the biggest problem that you run into trying to find one is which one is the right fit. Now, just like trying to buy a new welder, anyone that you ask for a recommendation is only going to tell you what they use, and they're going to insist that it's the best because they have no experience with anything else. It's truly a nightmare. This step isn't necessary at all. It's actually just a cheater trick. Useful info tidbit that I've picked up over the years. If this is level and sitting level on the chassis, then when I scan it, I can utilize this line right here, which is a straight line, and I can use this face of the blue tape as a plane. So I can basically manipulate or move the model and put it wherever I want in CAD. It takes the guesswork out of alignment in the different softwares that you have to work with or whatever. My biggest struggle is that I don't want a toy for a scanner. I need something above that hobby level, but I don't want to break into the 5-figure range like most professional grade scanners come with. I need something that's right there in the middle. I need precision, I need speed, and I don't want to put hundreds of stupid little sticky dots all over my project since that takes up a ton of time. You probably noticed earlier that I still have dots under the hood of the Lancer from the last scanners I was testing out, and I really don't have the hours available to peel them all back off. It's just a time suck. When 3DeVOK reached out and asked if I would like to try out their new MT model on a project, I knew this was going to be a perfect fit. This laptop that I have here is pretty powerful with an i9 processor and 64 gigs of RAM, but the graphics card starts with the number 1. It's pretty terrible for working on anything that relies heavily on a graphics card to process. Just for what it's worth right now, I've been at this for 6 minutes. While most scanners require a minimum of a 3060 graphics card, the 3DeVOK MT works flawlessly with my little 1650 Ti. And that's just the beginning. The 3DeVOK MT doesn't really seem to care how you use it. In other words, I don't need a bunch of little sticky dots. I don't need foot powders or magical sprays or anything else to make this thing work the way that everybody typically has to make scanners work. I mean, all I really do is just point this at whatever I want to scan and say scan it, and it does the rest. It's so intuitive that I could probably just give this to anybody and they can make a scan themselves with little or no experience. So it looks like we've got all the information I need. Obviously I need all that data inside of there. I need the face of this, these mounting points. I need that hole. I need all of that information. The rest of this, everything else around here, we can just delete that. Now, in my experience, usually it's down to the software. I mean, obviously the scanner itself should perform great, but the software is really what makes it. Is the software intuitive? Does it work extremely well? Does it give you lots of options? Those are the things that we typically want to see. Now, in the case of the software from 3DeVOK, yes, it is very intuitive. It is very easy to use. And when it comes to cleaning up your model, all you're really doing is going in there and saying, I need this data or I don't need this data. Whatever data you don't need, you can pretty much just highlight it and delete it. And typically speaking, the least amount of data that you have on your model, the better your computer or your system will perform. This really only takes a few minutes. Well, I think that ought to do it. We've got it down to 208,000 triangle faces. Now, this little laptop is not very good, but my big computer down there, this whole thing here, that's very good. It can handle a model like this, but there's no reason to really push your system if you don't have to. If you just need this as a reference, that's it. My CAD software of choice is Onshape. I've been in the CAD CAM game for about 14 years now, and I've switched softwares a total of 4 times. Onshape is the most powerful stuff that I have found. Now, I am not going to go into depth on how I modeled this system because it would be an extremely long video and I would probably lose most of the viewers, but if you want to learn something like CAD modeling, just let me know down in the comments. I've been kind of toying around with the idea of offering classes in Onshape. And for what it's worth, CAD really isn't that hard to use. And if you're in the fabrication game with zero CAD skills still, you really need to get on it, because fabrication these days revolves around it. Especially if you run a fabrication business, you kind of want to stay afloat. Okay, normally I absolutely hate hot rolled steel, but I cut all of mine up, all of my cold roll up, to turn into welding coupons for weld metal, so had to get this sheet. This is our 1x1 aluminum for the schnoz bar, and of course we saw the chromoly earlier, 1" 095. You do the math on it, it's about 230% more springy-er. So we're gonna have some steering issues until I figure out or build the front one. I'm going to start with the steel, because while it's cutting and doing what it's supposed to do, I can go bend the sway bar. By the time I'm done bending the sway bar, this should be all finished being cut out. Then I can switch to aluminum, do all the fab work with this, and then by the time the aluminum's done, the thing's basically ready to go together. Now, this tool that I'm loading up here is called a water jet, and everybody asks me who makes it, so I'll tell you. The water jet is made by a company called Wazer, and it has become one of my new favorite tools here in the shop. I recently remodeled my shop and completely dedicated this room to that water jet itself. I call it the Wazer room, or sometimes the Wazer station. It's really cool. This is how we set the cut height. The tab of the cap goes right underneath the nozzle, and that stays fixed the entire time. But either way, the Wazer will be handling all of the cut needs of this project, since it literally cuts everything that you put into it. Let's get to work on other stuff. So in order to get my bar measurements, right, I'm just going to take all the data and information I have straight off of this friggin' drawing and then apply it to the tube. So if I click onto here and go down to sketch 9, which is the sketch for the bar itself, this line right here represents the center line of the entire tube. So if I click here and I click there, I can see that the distance after I click the measure button is going to be 28.976007 inches. That's a bit too much. I'm going to go 28.875, divide by 2, that's the center of the bar. Now I need the total length of it, so I'll just click all of these lines, and it should give me the total length of tube that I need, which would be 44.663 inches, or basically 44 5/8 to each end, but we're going to cut it a lot longer than that. I think I'm going to go, let's go like 50 inches, just a round number, and bend out this way, bend out that way, and then cut off what we don't need when it's on the car. So 25 is our center line. We can measure out here minus the start of the bend distance, which Rustfab puts on the side of it. Looks like for a 3.5 inch center line, we need a 6 1/4 offset. That's a little embarrassing. I don't remember if it goes on the outside or the inside. I just looked it up, so since the bend is going to be here, then this block needs to be on this side of it. So it's from the face of the block to the start of the bend, that's the offset. How embarrassing. But that's alright. So this is why it's nice using a flat level surface to install your clamp blocks, because once we put it into the bender, and you know, both of these need to be on the same plane, right? So if the clamp blocks are nice and flat, then the bend will be nice and flat. Pretty easy day. So admittedly, it's been a little while since I've bent a tube, and I know that I was kind of made famous 10 years ago on YouTube for bending tubes, but this is definitely a skill that if you don't use it, you're gonna lose it, and I cut my tube way too short to be bent to a full 90 degrees. I mean, worst case scenario, actually best case scenario, it's exactly 90 degrees. Worst case scenario, it's a little bit off, which I can tell it's a little bit off. Now, as much as I want to say that it's close enough and it will probably be fine, I just flat out know better. Besides, I had to go buy an entire stick of chromoly for this job, so it's not like I can use the excuse of not having enough. I just bent a second tube with the proper dimensions on it. And I heard the water jet shut off, so looks like we're done here. Let's see what we got. Yeah. Love it. Yeah, that looks sick. That's nice. That's a nice looking piece right there. I like that. Well, these things are called fabricated tube mounts, and there are many ways to make them. The most common way you see is to just weld a washer to one side of them and mount the thing up. Sometimes you'll see people even welding like a nut to the inside of the washer so that way a bolt can fasten to it. I mean, like I said, the list goes on. Lots of ways to make them. Now, I obviously cut mine out since the mounts need to be slotted to allow the control arms to be adjusted. And the tube mounts themselves are made from chromoly, and the discs are made from mild steel, and they are stuck together with ER70S-2 filler wire. There's no need to use fancy chromoly filler or anything like that because these are not going to be heat treated. Now, while I was welding up these tube mounts, I was simultaneously cutting the aluminum wings, which is what the sway bar will mount to when this whole thing is finished up. And they finished cutting not too long after I finished up these tube mounts, which means the timing on this job is perfect so far. I'm feeling good. I love it! So, looks pretty clean. I can work with that. Obviously, we want the slot level, so we're gonna get this centered up, and then I can peek in there and kind of get it centered, level, etc. And then when we go to actually put the center section in here, then we can make any fine adjustments and anything else like that that we need and tighten them down all the way. Holy waffleberries, I need to clean the lens on my camera. But either way, dang. That looks sick. Oh man, I can't wait to do this. You know what? I gotta get the studio lights on and all that other good stuff, and then we can put this in there, and I gotta clean my lens. It's a new day, and I am completely pumped about it. Not only do I have the day off from my other tasks and duties around here at TFS and Weld Metals Online, but I get to spend the entire day working on this project. If you own and manage a business, you know exactly what I'm talking about. But this high can only last for so long, as this is the first encounter with the very first problem on this project. That grease zerk is going to be a problem. I did not account for that in my model. Okay. You know what, we're probably just going to pop that sucker out of there and not use it. Because I don't quite have enough space with it. But, damn! That looks friggin' sweet. I love it. So in order to keep this from killing my buzz so early in the day, I moved on to the schnoz bar. Now if you were looking in the beginning of this video and you started wondering what this gold thing hanging off the bottom does, the answer is absolutely nothing. The schnoz bar is a nod to the Honda boys and their love for attaching useless junk to their cars for street cred from a bunch of dudes. It's a lot like the Jeepers and their doorless duck dash mods. The Beaks bar, as it's commonly known, is the most popular brand of subframe brace that's supposed to attach to the lower control arm mounting points, but that's not how you usually see it mounted. It's most commonly mounted to an existing subframe brace, which defeats the purpose, because if your brace needs a brace, then what good is the brace if it needs bracing, right? Funny enough, I used to rant about these things all the time, and now here I am building one that's equally worthless, but it looks cool, and I decided to call it the schnoz bar because that's a synonym for a beak. Now, I don't know if you guys called this out yet because I completely missed it when I was building it, but this schnoz bar is mounted completely incorrect. I did ultimately have to go back and make another one with some new brackets and fix it, but to be fair, I had a lot on my brain. Okay, so I've spent I don't know how many hours now just staring at this and then ordering parts and getting ready for stuff, thinking if I had an alternative solution to this. Well, I did find one, and it's actually smaller brackets than this. Right, so Energy Suspension makes one that's just a little bit shorter, and it doesn't have this much of ear on it, if you will. So, smaller, tighter packaging, which gives me a little bit more space in there, would allow me to space this a little bit further off, or actually, I could recut these wings so that way it's a little bit higher, and then the bolt pattern is a little more narrow, puts the sway bar up just slightly higher. The whole works, right? And I'm like, you know what, I'm not going to do that, because I don't want to bother cutting new wings for this, right? But then I was about ready to get started on welding this piece to our mounts, and then I was just like, wait a second here. If I would have designed this just a little bit differently, I would have had the wings completely cover up the mounting holes. Like, that would have been pretty cool. I could have packaged this a little bit differently, you know, a more unique design, something like that or whatever, but I already ordered my friggin' parts. So I'm not recutting these wings. I don't know. It's one of those things that bothers me, but hey, it is what it is. So I'm just going to get this welded on. And at the end of the day, if I really don't like this, I'll make another one. Preparation is key for getting a good solid weld, a strong weld, a weld that even looks damn good. And this took a lot of preparation, more than I really care to do. And it's the reason behind why I absolutely hate hot rolled steel. Here's a brief explanation. This is a condition that we call bright metal. If you see the dark gray stuff, that's called mill scale. We don't want that. And the hot rolling process, or hot rolled steel, produces mill scale. And you can't weld through that stuff. It sucks. And that's why I hate to work with it. So your best alternatives are going with cold rolled steel, or CRS for short. Or if it's above 3/16 inch material, switch over to P&O, which is short for pickled and oiled, which is basically hot rolled steel with the mill scale chemically removed. That'll save you a lot of grinding time, because we all know that grinding is stupid. Behind here are fireball shims, 1, 2, 3 blocks actually. So I'm using the 2-inch side because that's the spacing I want. This is positively your very, very last chance to make sure that your standoffs or your mounts themselves are where you want them to be. As in, I want them level and I want them centered where they're supposed to be according to the model and of course on the car itself. Because if these are off, well, your part's gonna suck. I mean, there's kind of no way around it. So double check, triple check, quadruple check, trillion check, whatever. Check as many times as you need. So while I weld this up, I just wanted to personally say thank you guys for all of your continued support. This year, Weld Metals Online turned 7 years old, and we just passed our 60,000th order. It literally means the world to me that you guys trust in our product and you choose to support hardworking USA-made brands. So again, thank you guys, seriously. Never thought this would happen. Now, in order to maintain the position and angle of the tube mounts on the chassis, an order of operations must be followed. First, I laid down 3 tacks on the front that spread out evenly on the brace. Then I snuck in behind to throw down a solid weld. Now, the weld itself only covered about half of the total length because that's all the space that I have, but it's more than enough to make sure that this part maintains all angles and positions. Now, if you're going to build something similar like this for yourself, then try to get as many tacks or welds on as possible before removing the part for final welding. Now, I want the brace to cool down completely before I take it off the car, so I decided to shift my attention to the sway bar. Now, these rings right here are meant to keep the bar from shifting back and forth, which is something that happens occasionally on bars with long straight sections. These are cut from 1/4-inch steel. Oh, and you know what? I almost forgot. In case you didn't know, my hardware for the sway bar ends came from McMaster-Carr. And one of the very convenient things that they have, or they offer, is free CAD models for the hardware that you want to use. That basically translates to, I don't need to mock up the sway bar in order to get measurements, since the dimensions are already on my model, and the parts that I ordered, the ones that were shipped to me, are the ones that I used for the model. It's a really useful trick if you're ever modeling parts. Okay, so I know that the distortion was extremely low, if not 0, because I can still put the blocks in tightly. And I don't have anything to worry about. Yeah, there we go. So both the blocks still fit in nice and tight. So distortion was, well, practically none, if any. With the sway bar cooling down, I went back to the brace, which is now ready to handle. Now, I started by finishing the other half of the backside weld before trimming off the remaining tubes in the bandsaw. This really cleans up the look a little bit. I also welded the front face of the tubes to the face of the brace before grinding all of it nice and smooth. Now, one thing I didn't do was model the anti-shift rings because I wanted to place them myself with everything settled on the car. While this is kind of annoying to have to mock it up again just to take it all down, it ensures that the rings land in the correct place. I also didn't tack them on the car to avoid potentially melting the bushings. The rings just got some small beads on the top and bottom to keep them in place. I think I put like 6 dabs per bead just to make it nice and uniform. Stuff sprays like powder coat. Yep, that'll do. In the event that you are a powder coat aficionado, I would like your recommendation. I'm also looking for a powder coat setup. I don't have tons of space, but mostly for small parts, good quality tools, you know, somewhere above that hobby toy level, but I'm not opening up a powder coat shop. So if you've got any recommendations, please let me know, because I would much rather do that than spray paint. But speaking of spray paint, I'm going with the colors that I had in the model. And of course, modeling them in the model with those colors kind of helps you see if you like this or not. So red for the sway bar, beautiful looking color, flowed nicely. For the main brace, I decided to go for a color match, which is actually not dead on. It looks pretty close in person, but here in the light, it looks much brighter than the actual car in the background, but they actually do match extremely well. Very, very close. And finally, for the schnoz bar, we gotta hit that gold flake. Man, I love this stuff. Back when I was injured just out of the Navy, I had this acupuncturist from Africa, and yeah, actually he was from Africa, but he told me that gold is the color of happiness. And I always smile when I see gold. It always stuck with me. Makes me happy. But all the happiness in the world can't keep away the fact that this can decided it wanted to fart itself all over my part. The can was getting a little bit old, so I had to resort to flooding the crap out of this thing, and all of those drips are going to come back to bite me in the ass, but we got coverage at least. I'll just have to fix that tomorrow when all of it dries. Like, no big deal. Now, the aluminum parts you saw earlier were given a brush finish, and the solution you saw me dribbling on there is hand soap because it has pumice in it, it gives it a really nice, smooth finish under the clear coat. And the clear coat on all the parts is wheel paint because that stuff is damn near indestructible. Now, the next day started off with a trip to the greatest hardware store in all the land, McFadden. If you are in the Southwest, you should know about this hardware store, and literally anything that you want, including all of my fancy hardware that I'm using here, is in this store. Now, just for fun, be honest here, if you know of McFadden, comment down below right now how many pens you have sitting on your desk right now from McFadden. This tip is the one that kind of blew up and farted all over me yesterday, or all over that part. So I'm going to take this tip off, put it onto there, and hope for the best, because they probably spray differently, but it's all right. As long as I get me some gold, we're good, because there's not much of this left. Literally squeezing out every last drop I have in this can. Come on. Yes, just a little bit. A little bit. Come on. Well, the sides that's visible looks pretty good. Clear coat will fix most of that. With the schnoz bar being left to dry, it was finally time for some assembly, starting with the main brace, which was fit loosely in case I need to adjust it once everything is all put together. Now next comes the wings, and the second that these got bolted down, I started getting really excited because the brushed natural finish of the aluminum against the color matched main brace really made this thing pop under the car. I mean, it looks so friggin' clean. And the precision cuts from the Wazer, everything is just dead on between these three pieces. They are near perfect. Now, before the sway bar can get bolted on, of course, we got to add some hardware, starting with the Heim joints on each end. And I did measure these before I installed all of them to make sure that both sides had the exact same thread length sticking out of it. Now, it's not like I'm ever going to really need a lot of adjustment, if any, in the future, but there's still plenty of thread just in case I need to move it or adjust it or anything else like that. If there's some slight changes, we have some wiggle room. I also added the polyurethane mounts with this stupid messy included goop, and I tossed it all on the car. So all of my hardware is metric on here, except for the end links, because I couldn't find metric Heim joints. So those are all standard. Unfortunately, it doesn't match, but at least all of this does. It's all metric here. I want to get that schnoz bar on. I sure hope I don't get taught a lesson on being impatient. The schnoz.
shit.
No. Damn it. I'm being taught a lesson. Nothing I can do. Well, it is what it is. I should have. Oh, you know what? Screw it. I don't care. I can just go get some more paint and redo it. I have a second label here. And besides, I have the machine that makes more of them. I am just too impatient. I want to see this thing done. Aside from the messed up paintwork, that looks pretty damn good. Ooh, I love it. Just damn that paintwork. I should have just, man, I should have waited like, I don't know. I should have just built the end links and then came back and put the schnoz bar on, but okay, let's build these end links. Man, you wouldn't normally think that something like the messed up paint job on the schnoz bar would derail me from, you know, this job or whatever, but for some reason it did. I literally went from being super excited and focused to completely distracted and rather annoyed. Just thinking about that paint job that I screwed up and rushed, I'm just, yeah, you know? So I ended up having to cut 2 sets of spacers because I wasn't paying attention to the first measurements and I cut them way too long, which made my static angle of the sway bar sit upward, which would cause the sway bar to yank backwards every single time I hit a bump. Sway bars don't like to work that way. So I ended up having to cut a second set, but this time I paid attention to my measurements and everything came out peachy. There. Last bit for the test drive, tighten, tighten. Whoa, that back end is stiff. We'll take it out on the street real quick. I'm gonna see this. This back end is stiff. Like that may be a little bit too much sway bar. I don't know. Let's give it a little shake down here. That back end is stiff, man. This front end just feels like it just wants to slush. That back end is solid. Wow, this thing handles like a Viper. Entry ramp here. Test its flex. I can feel that in the back end. This is, holy crap. This is so dope. I mean, it's clanking around a little bit. You can hear it like off the muffler. Only slightly. Here we go. That back end just sticks. Dude, this is freaking awesome. It feels like I'm on coilovers. So if you like what you just saw there, drop me a sub and double check that you are still subscribed if you're already subscribed, because YouTube is doing that stupid unsubscribe silently nonsense again, which is really annoying. And don't forget, next episode, I'm gonna build another subframe brace, but this time with something a little less technological. See you then.